All right, switching gears here just a little bit for a moment for congruent figures. We will also do some congruent figure proofs, but first we need to talk about congruent figures in general. And you do need to pay attention to detail here because order will matter on almost every problem we do. So remember we talked about isometric transformations in our last unit, which are rigid motions in the plane preserve the size and shape of the pre-image and image. So that's what we want here, size and shape. The three rigid transformations we learned about were reflections, rotation, and translation. So the only transformation that was not isometric was dilations, which is any kind of stretch or shrink of your image. All right, congruence. Two figures are congruent if and only if one can be mapped onto the other by one or more rigid motions. Okay, so mapped can be any of our three rigid motion types. So here it says, describe the order of rigid motions at the right. So if this was our first rigid motion, that'd be a translation. Of B to B prime. And then here it looks like we'd have a reflection. Over this unnamed line. Okay, a congruent statement. This is where our order is really going to matter. Relates one identical object to another by identifying the corresponding parts. Actually, let's, instead of parts in general, since we have two blanks, we want corresponding points and sides. Okay, or if we lump those together, we would call them parts. Use the diagram above to write a congruent statement. So again, this is where it's going to matter your order. But since these are all labeled with the same points, it's a lot easier. So I can say triangle BCD. The first triangle can be in any order you like, but your second triangle has to be in the same order. So I'm going to say B double prime, C double prime, D double prime. And this is harder when they're not labeled with the same letters. It says describe the rigid transformations, then write the congruent statement. So from here, let's see. I think this would just be a translation. Let's count. 1, 2, 3, 4, 5, 6. So write 6. Down 1, 2, 3. Let's just double check with another point to make sure that worked. 1, 2, 3, 4, 5, 6. 1, 2, 3. And I think they would all be that way. Okay, so we're going to say it's a translation. Okay, so we did T of xy is x plus 6 and y minus 3. And again, for my quadrilateral, and for quadrilateral, instead of a picture like our triangle, it's just quad. QRST, let's say, is congruent to quad. And then I have to go in the same order. So if I start with QRST, I have to do UVWX. And that's important because then we're saying Q goes with U, R goes with W, S goes, or that should be a V. Q goes with V. S goes with W, and T goes with X. Okay, this transformation, let's look. At first glance, I think it's a rotation. Okay, so we'll say a rotation of 90 degrees clockwise. Rotation is our large R, about the origin of 90 degrees. Let's see, because like this is -5, 1, and then we have 1, 5. So it is a rotation of 90. So let's say I start with T this time. Again, it's a quadrilateral, so we'll use quad. T, Q, R, S. Again, you can choose any order for the beginning, but then you have to be careful and use the same order. So I think T goes with X, Q goes with U, and then I did R, R goes with V, and then I'll have W. Okay. Transformation here, I believe, is a reflection. I think we're reflecting, that's our lowercase r, over the x-axis. Okay, so when you get to be more than four sides, like this time we have 5 sides, we are just going to name it with letters only instead of having a prefix here. So a triangle is just the picture of a triangle. Quad is this abbreviation of quadrilateral. But after you get to more sides, then we'll just use the points. So let's do A, B, C, D, E. And then again, I have to match them up correctly. So A goes with J, B goes with M, C goes with W, D goes with Y, and E goes with H. So any order for the first one, but the second order has to match. Corresponding parts of congruent figures are congruent is a long statement that we're going to use a lot when we do proofs. So instead of writing it out every time, we're going to let you use C, P, C, F, C right here. And it's saying if 2 polygons are congruent, then their corresponding parts, their sides and their angles, are also congruent. So we use it a lot specifically with triangles. We'll use C, P, C, T, C. So instead of figures, we use T for triangles. But it is a reason we use a lot in proofs, and it's long, so you can abbreviate it. So here it says quadrilateral ABCD is congruent to quadrilateral MN and OP. List all congruent angles and congruent sides. So our angles are fairly easy because it's the same order. So angle A is congruent to angle M. Angle B is congruent to angle N. Angle C is congruent to angle O. And angle D is congruent to angle P. So that's all of our angles. And then we can do sides. So AB is congruent to MN. Again, I'm just using the order here, AB, MN. AC would be MO, and then that should be the only 2 sides I have with A. So with B, I could also have BC, which is NO. And then for C, I could also have CD and OP. AB, AC, AC, CD. I think I used C too many times here actually. So let's change this from BC to BD so that each one is used twice. BD would be NP. Okay, so now B is used twice, A is used twice, C is used twice, and D is used twice. And likewise for my other figure. Okay, next page. Determine if the figures are congruent. Explain your answer. So I'm going to say no. For this first one, it looks like all of our sides are congruent, but our angles would not be. Like this is an obtuse angle, this is an acute angle, and these are 90. So we're going to say no, angles are not congruent. And then on this one, similar, or really just the opposite, it looks like all our angles are congruent, but our sides would not be. If this is a square and this is a rectangle, our sides are not the same from one figure to the other, so we're going to say no. Sides are not congruent. All right, practice. Triangle ABC is congruent to ZYR. Name the transformation that occurs in each picture. So let's take a look. It looks like more than one thing is happening here, actually. Oh, here. It's like in 2 steps. This is what happened. It's our composite transformation where we did more than one, but these are our 2 steps to get there. So it looks like in the first one, we're rotating 90 degrees counterclockwise, so negative 90 degrees actually. So let's go ahead and put that here, rotation, or I'll use my shorthand, lowercase or uppercase R around the origin, negative 90 degrees, or you could say positive 270. Okay, then it looks like here we're reflecting, that's our lowercase r, over the y-axis. Determine if QRST is congruent to PLKJ using a sequence of isometric transformations. So this one was kind of stepped out to us, or stepped out for us, but we want to kind of come up with them more on our own on this one. So I would say we probably either want this figure to go on this side before it moves down or down here before it moves over. Let's think. So if I were to reflect, for example, let's see what that would look like. So a reflection, it doesn't look like would help us, because if I were to reflect that again, I would still need this piece to match up with this piece. So let's try something else, because my short end's on the wrong side. So let's try a reflection this way. So let's do T prime, Q prime, R prime, and S prime. That might be getting us somewhere. Because now we have my short side and short side. And then I bet from here we could just translate. We can move them all the same over and down. So let's count out what that would be and double check. So let's go from S to K, or S prime to K. 1, 2, 3, 4, 5, 6. 1, 2, 3. And then we just want to double check that. So over 6. 1, 2, 3, 4, 5, 6. Down 3. That works. 1, 2, 3, 4, 5, 6, down 3, that works. And last one. That would work. Okay, so our sequence was first a reflection, our lowercase r, over the x-axis. And then our second was a translation of our points, where we're going right 6 and down 3. Okay, and because we could map them onto one another using our rigid transformations, that is proving that they are congruent. So today you are working on worksheet 5.